Okay, today we will be talking about balancing chemical equations. So you will need this note sheet out and flip to the back side. We will do example 1 together. Alright, when we balance chemical equations, it's really important to know what you have on the reactant side and what you have on the product side. So what I tend to do is I draw a line right down the middle in between both sides. And then I need to tally up or count up the number of atoms that I have on each side for each type of atom that's present. So I start in the beginning here. I see there's a sodium. When we balance equations, we want to think about coefficients. A coefficient is a number out front of my compound that I have listed. So if there's no coefficient listed, we can assume that it's 1. And typically unbalanced equations start out with having a 1 in them for all of their coefficients. Okay, so let's take a look. Let's see how many sodium atoms we have. If I have a coefficient of 1, the next thing I want to look at is the subscript on my atom symbol. And if there isn't one listed, we can assume that it is also 1. So to figure out the number of atoms I have present, I always take the coefficient times the subscript. So in this case, I have 1 times 1, which is 1 sodium atom. Now, you have to be careful. Sometimes particular elements will be in one compound and they'll be also in another compound, so you'd have to check to make sure that wasn't the case. For example, instead of calcium here, I could have had sodium as well, so I would have to count up the total number between every single compound listed where that element is represented. But here it's only in this compound, so I have 1 sodium. The same thing is for oxygen and hydrogen. I also have subscripts of 1, and the coefficient is 1, so I have 1 of each of those. And then I move along and I see I have calcium. And in this formula, or this compound, I notice the coefficient is 1, and on the calcium I have a subscript of 1. So 1 times 1 is 1 again. And then I list bromine. For bromine, I have a 2 here for my subscript. So I have 1 times 2, which will give me 2 bromine atoms. So you'll do that for the reactant side, and then we do the same thing for the product side. I tend to stay organized, list my elements in the same order on both sides, so I can see more clearly what is balanced and what is not. Okay, so I'm going to look for sodium first, and sodium is in this compound. Keep in mind, things on the product side of your reaction they should have the same element types, but they may be arranged differently because in a reaction you're making something new, making a new product. So in this case, sodium is with my bromine, and my coefficient here is 1, and my subscript is 1. So 1 times 1 is 1. For oxygen, I notice oxygen is inside these parentheses, and there's a 2 behind those parentheses. The 2 here is a subscript for this stuff in parentheses because it's listed behind those parentheses. So if I wanted to figure out how many oxygens I had, this 2 is basically saying I have 2 of these units. And if you remember your polyatomic ions, this unit inside of here is called hydroxide. So I have 1 oxygen inside and 1 hydrogen. Okay, because those subscripts aren't listed, so I can assume they're 1. To figure out the oxygen number, I take this outside subscript, 2, times the 1, and I will get 2 oxygens. Same goes with the hydrogens. There is a coefficient of 1 out front, so for calcium I have 1 times 1 to get 1. This 2 only goes with the parentheses it's matched with, so that's only for the O and the H. Calcium's on its own, it's not inside those parentheses, so the 2 doesn't apply, so there's a 1 here. For bromine, I have 1 here, so I have 1 times 1 is 1. Alright, so everything's listed, and now we have to see what's unbalanced. So just by eyeballing it, I can already see, well, my oxygens and my hydrogens have different numbers, so those are not balanced, and my bromine is also not balanced on either side. I need to have equal numbers. The reason we have to have equal numbers is because this demonstrates the conservation of mass. So I can't randomly create stuff on this side or destroy things on this side and take things out of the equation. Everything has to stay the same on both sides as far as the number of things I have. The first thing you want to look for, or the first element to pick and try to balance out, will be the element that's only listed in one compound on both sides, not an element that may be in two different compounds. So in this case, I see that bromine follows that, and bromine is one of my unbalanced things. Oxygen and hydrogen are also that case, but oxygen and hydrogen in a lot of other cases can be split up between different elements or different compounds. And so those types of things we try to balance last. So you should always balance oxygen and hydrogen last. It's too complicated if you do it in the beginning. Alright, so let's take a look at the bromine. That's my thing that's unbalanced. So I find bromine on this side of the equation. Since I can't take one of these bromines on the reactant side out because we have to conserve matter, I have to try to get two bromines on the product side. And to get those two bromines, so to speak, that's where the balancing part comes in. So if two bromines started over here, then there have to be two bromines ended up over here. So you look at your numbers and you try to decide, all right, what can I multiply by to get my number to change? And that number you're multiplying by is your coefficient. So on this side, I say, okay, what number can I multiply by a 1 to get to 2? Well, 2 times 1 equals 2. So that will be the coefficient that you put in. So you find your bromine, all right, it's here, and I'm going to change this out front, this coefficient, to a 2, because then I'll get 2 times 1, and that will be 2 bromines. So every time you put in a coefficient, you want to rewrite the equation and tally everything up to make sure nothing else has changed as a result of putting in that coefficient. Okay, so let's go ahead and tally up again. Now on the reactant side, I didn't put in any new coefficients, so all of these will remain the same for now. But on the product side, I changed some stuff. So the first thing I want to look at is where I put my coefficient. I listed sodium first on this side, so I'm going to try to list everything in the same order. So let's go ahead and take a look. This coefficient of 2 now means I have 2 times 1 sodium, so I get 2 altogether. And then oxygen and hydrogen have not changed since I didn't put a coefficient in front of this. This stayed the same. And then calcium is 1. And bromine should be balanced because that was our intent by putting the 2 in. So if I take 2 times 1, then I get 2 bromines. So this is good now. But as a result of putting in that 2, now I have 2 sodiums on this side and 1 sodium on the reactant side. So that's something I'll need to balance next and take care of. Okay, so as soon as you see, another thing gets unbalanced, go ahead and balance that, but keep in mind, always do hydrogen and oxygen last. Okay, so sodium is my next thing that I want to change. So now I ask myself the same question, but I'm switching sides. I go, all right, well, there's 1 sodium on the product side, or the reactant side. So what can I multiply by 1 to get 2? Well, the answer in this case is the same. I need to multiply by 2 again for my sodium. So I find my compound where my sodium is at, and I multiply by 2. Okay, let's go ahead and take a look at how this has changed. You will want to rewrite this equation. Again, for the lack of space that I have, I'm just going to go ahead and change the numbers. I'm going to tally it up with what I have written currently. Okay, So now I have 2 times 1 for my sodium, 2 times 1 for the oxygen, and 2 times 1 for the hydrogen. So now if you look, it just so happens that hydrogen and oxygen balanced each other out. So a lot of times that will happen, and that's why we keep those to the end. Okay, so this right here is going to be your final equation. So the final equation will keep those coefficients in, and this is perfectly balanced. So this gives us an idea or shows us what we need to do as far as putting in how many reactants and what kind of products we get out. So conservation of mass is preserved here because everything is equal on both sides. Okay, that is it for balancing an equation. So we will go over a few more examples tomorrow. I just wanted to introduce you to the topic, so make sure you have this down. There will be a short couple questions along with the naming quiz that you have tomorrow, so make sure you're studying that, and make sure you see me if you have any questions.